We're going to start out looking at application and database management. These usually go hand in hand. If you look at the way that most programs and applications work, and this would include operating systems as well, there's always a database at the back end. We're always storing data of some sorts. Your operating system, when you change the color on your desktop, when you change the way that your start menu looks, that information gets stored in what Microsoft calls the registry. The registry is just a simple database. Right? It just stores the information. When the operating system loads up, it's pulling the information out of that database to make your computer look the way that you had intended it to look. So that's just a simple example within a desktop environment. If you're building custom applications for a network, say like you're a bank, you're storing obviously all of the checking information, all the savings information, and all of the financial information that's being modified, added to the system, removed from the system, all electronically from day to day, from second to second pretty much. So in application and database management, and this is pretty much true in all the management systems, we're going to take a look at what the event and performance metrics are. So the events are the things that are actually occurring. Think of an event as basically the update or modification to the database. That would be an actual event that's occurring. Whereas the performance is how fast is that occurring? How many events, how many updates are we getting within a particular time frame? So we need to have these event and performance metrics built into the applications themselves. In the early days, the applications weren't concerned with management, weren't concerned with being monitored, and so you had to have additional programmers come in and figure out a way to be able to monitor, be able to manage the applications. So again, an event is the database. Transaction is another term for it, or update. So anytime that we're recording information into the database, reading information from the database. Instrumentation refers to the embedded performance metrics. So we actually create, the application developers really actually create little components of software that are included within the application, little modules that are included within the application that will report the activity of the application, and that's referred to as the instrumentation. Agents are the actual components, the pieces of software then, that are utilized to collect, format, and transmit the event and performance metrics from the application to our management console. So an agent is another piece of software. It's retrieving events as they occur, it's retrieving the performance metrics as they occur, and then sending that back to the management console. And as you'll see as we get into this a little bit later on, we need to have some sort of a protocol that is used to transport the agent across the network. So the agent is just the data itself, really. We're grabbing that from the instrumentation. The agent takes the data from the instrumentation and then is going to put it in a certain format, but it still needs to be encapsulated in a protocol that can be used to send it across the network, and you'll see that SNMP is one of the most commonly used ones. There are two primary network variables, I should say, affecting our distributed applications. They would be latency and bandwidth. So distributed application, what does that mean? Go ahead, Marlene. Yeah, you've got two or more components operating in two or more places, servers, desktops, within the network. Could be within the room, could be within the building, could be within the site, could be geographically at various sites. And so the big issues there obviously are going to be latency and bandwidth. Make sure we understand the difference between the two. Latency in this particular case deals a lot with the server processing itself. For instance, if you go and you make a transaction at the bank, you've got a web interface, you're typing in the information as far as how much you want to transfer, you click on the submit button, it now goes back to the web server. The web server now has to run some sort of a program that figures out what it is that you're attempting to do and then accomplish that process for you. More than likely, it also has to communicate with another server that's running the database to actually record the transaction that you're attempting to make there. And so that whole process takes a certain amount of time. So that's the latency issue. So we don't click the submit button and then boom, see our confirmation pop right up, generally speaking. Although most cases it is pretty fast, but it's not instantaneous. So the time from us typing in the information, clicking on the submit button, actually having that transaction recorded in the database, and then the confirmation being sent back to us, that would be the latency time frame. Now, bandwidth certainly is going to affect that in some respects because the data has to be sent over the network. If we have a dial-up connection, it's going to be slower than if we had a T1 connection. But always, you got to remember that just because you increase bandwidth is not always going to reduce your latency, because it could be we have a slow server. You know, maybe that server is running a 286 chip, an old XT box, right? So that would be a very slow processing device. So that's what's creating the latency. You could have gigabits per second of bandwidth and you would still have a slow system because the server is actually creating the latency. But those are certainly the two things that we need to consider. We start getting into some of the terminology now that's used within the application and database management systems. So first of all, we have what are called the management objects, and they're referred to as the Application Management Specification, or AMS. And what AMS defines then is things like distribution, dependencies, relationships, monitoring and management criteria, performance metrics, and all of that then is processed by the agents. So in other words, we've got an application that records transactions, as we've been talking about. So one of the performance metrics we're going to take a look at is how fast those transactions are occurring. So that would be an object, and when we talk about objects, we're really talking about software components that are capable of recording transactions and how fast they're occurring. So somebody sat down, written some code, created a management object then that relates back to the agent initially, and then eventually back to the management system, what is occurring. And then we have Application Response Measurement, or ARM. This is an actual API that can be used by our application developers so that we can measure several key application statistics. So think of it as the objects being built into the software. So this is our application. We have all these objects that are built into the application that record information or allow us to record information about various components. So those are the application management specification items, the AMS objects. So for each AMS object we have now, we're going to have an agent, which is another piece of software that needs to be able to grab the information from these objects. The component then that goes in between the agent and the objects is called an API, or an Application Programming Interface. This is a very common component in pretty much all aspects of computing. In fact, you might remember when we were talking about the top layer of the OSI model, we talked about HTTP, which is our Web Transport Protocol. And we said that the application layer includes APIs, so that programmers that write things like Microsoft Word and all the different actual programs or applications, if they want to use the network, so if we're in Word, we want to go to the File menu and we want to go out on the network to open a file, instead of the programmer that's writing Word to have to go through and create all of those networking components to make it all successful, it's already pre-built for them. All they have to do is access the right code at the application layer there, call on a method usually of the API, and once we call on the appropriate method, it's going to then package up everything from that application as far as the requests, send it out over the network, get it to the other side where the other end has an API that then hands it up to its application, right? And then we create that two-way communication between both of the applications. Again, I don't have to write that code. It's an API. It's already been done for me. So this is the same thing here. You've got an agent from one company and their management system that needs to access these AMS objects. Instead of having to write it specifically for every single application that's out there, instead the application developer provides this API, and so we have a little bit of consistency, flexibility, and ease of being able to access the information.